Hello, how are you?
I'm fine, thank you. How are you?
Good morning. Um, it's possible to connect your camera the first day. Hello, Laura, Adriana, Natalia.
Hello.
Hello. Happy to see a lot of people in the classroom today. How are you? Our first day. I'm sorry for we started one week later because I make a mistake. A lot of people. Very nice. Good adventure. We start today. Um, okay, I'm going to stop there to record this lesson because I want to record, but I'm going to stop now. Okay, nice. Now it's recording. Perfect. Hello to everyone. So happy to have these super beautiful online lessons. Probably will be better to be in the classroom, but okay, that is the situation now. Let's go to try to get the maximum. Okay, this subject that you know is called knowledge representation. Um, Knowledge representation in computers. The idea is to learn this subject. The general idea is to learn techniques to represent knowledge with a computer. There are many different techniques to knowledge representation, but we're going to put the focus in mainly in one technique. And the reason why we're going to do that is because only this technique needs more than one semester, probably. So I decided many years ago to try to learn one thing more or less deeply, and for the other techniques, usually what we do is make a work, a homework, where you can have a more general vision of knowledge representation with computers. But I prefer to do that because I prefer to have one techniques in a good level than have 5 or 10 techniques in a very low level. So we're going to use logic, programming in logic as um, knowledge representation. Okay, this is the reason why the subject is called knowledge representation, and we learn Prolog. That is the name of this programming language. Okay, so probably at the end, I will ask you to make a homework about a little research about other types of knowledge representation to have this general vision of this subject. Okay. Okay. Um, this day probably will be the day that I'm going to talk more in this way, because I want to start programming from first day. I don't want to spend a lot of time talking by myself and you listening, but the first day is necessary to make this little introduction. But probably I want to do today, at the end of the day, of the lesson of today, to start with your first program. Okay, you are going to program from today. If you wait until the end of the lesson, because now comes the long rollo, como I have to say in Spanish, the long el rollo, where you have the rule. I speak too much today, but it is not the usual way to develop our classroom. Okay, so first thing I have to tell you, just to tell about the word paradigm. I'm going to share the screen to, sometimes I want to work write this word because my pronunciation is not perfect, and sometimes I want to. Can you see my screen? I usually Google Translate to have to write your words here. Tell me what this word means to you. What this word tells to you? Paradigm. What that means to you? What means a new? What this means? That word paradigm to you? Can someone tell something about that? What that means? In your language or your knowledge about paradigm?
I can say,
Yeah.
I don't know if it's correct, but it reminds me of the Greek language, of the Greek word paradigma, which means example.
Do you know what means or not?
I think it means example.
Okay, let's go to start with the samples. Okay, perfect. It's like, for me, paradigm is like a new vision or a different vision of something. For example, I want to put this example. I repeat myself many times, but I want this example. It's like uh, everyone how to drive a car, have your driver's license. Do you have your driving license or you drive a car or not? Can
Yes.
you?
Yes.
Yeah. Okay. Um, think about if you drive a car and you want to drive a van, a big van, like a camper van or a truck. And what happens if you know how to drive a car and you want to learn how to drive a camper van or a truck? It's the similar situation where you have a bigger dimension of the vehicle. Um, Probably you have automatic transmission or not. There's some differences, but you can reuse almost everything you learn with your car. You can reuse almost everything to drive a camper van or a truck. It's only it's a very easy adaptation for people when we try to learn something in the same paradigm. That will be like a paradigm. All vehicles that drive like the steering wheel, you are sit in your in front of your steering wheel, and that's all. It's like cars, vans, trucks, and whatever. But think about what happened when you want to learn to ride a bicycle, or another paradigm will be think about if you want to surf. You start to surf. Anyone in the classroom tried sometime to surf?
I tried windsurfing for just 2 hours and
Just
yeah,
2 hours.
I fell off every 30 seconds.
Okay, it's hard. It's hard. If you want to learn and you think, or there's someone that never ride a bicycle. Everyone in the classroom, ride a bicycle or not? Everyone?
Yeah, I think so.
Okay, perfect. So if you know someone that don't know how to ride a bicycle and have a age around 20 years old, something like that, or can explain to you that it will be very, very hard to learn something like that, because you have to balance the vehicle with your body. It's very similar to surf. You have to balance over the board, and the board is over the sea and in a stable situation. And you are different ways to ride, but you don't try to reuse the knowledge to drive a car. You don't put over your surfboard trying to do something like that, managing your car or accelerate with your pedal. It's not, you don't reuse that. It's a different paradigm. You have to learn a new different way to ride this bicycle or surf. So for me, that is one of the most difficult thing one person more difficult task to learn new paradigms, something that is totally new. You can reuse things that you know from other field and try to adapt to this new one. So in programming languages, that's very common because they are a big paradigm of programming that is called imperative programming. Imperative programming. That is mainly, probably, I don't know, today around 80% or more of the programming languages are imperative, like C, C++, Java, or Python, or Perl, or I don't know. So different programming languages are all imperative. It's more or less easy if you know how to program in C. Learn to program in Java is more or less easy because you have some differences. You have to learn the syntax, some extra functionalities, but it's more or less easy. Probably you can learn to program in Java if you know you have previous knowledge in Python, in C. Probably you can learn in 1 week or 2 weeks, more or less. You can start probably the same day. You can start with your first Java program. But if you want to learn from imperative languages to declarative languages, things change. Things change a lot because change from C to Java is more or less easy, but try to program from C to Prolog is not easy. Probably you can do that in 1 week, and probably you need here more than 3 or 4 weeks. It depends of your way to learn. It's very important too, because we have previous experiences with I was teaching this subject last 15 years, a little bit more. I think this is the 16th year, academic year, teaching Prolog. And at the beginning, my way to start this subject was totally different that I start today. Because I try at the beginning to do the same way that I did with other programming languages like C or Java. That's usually the way to learn this type of languages is talk about syntax and loops and how to define structures or something like that. Probably that don't tell you nothing if you never program. Don't worry about that, because only concepts about imperative programming. Don't worry if you don't understand what I'm telling you now, but you only want to keep that it's easy if you have this previous knowledge of one type of programming language to change to other programming language in the same paradigm, but it's hard to change from imperative to declarative. And what we realize in our students, what I remember, one person, one student who was the last subject he has to finish, and he spent 4 years, 4 academic years, studying this subject and trying to pass this subject, and he can't pass this subject. And he told me he was I don't a little bit more age than the rest of the student because he was a father. He has a son, very responsible person, and he told me, I don't know what happened with this subject, but for me it's impossible to pass. I did every other subject in my studies. This is the last one. I spent last 4 years trying to pass the exam. It's impossible for me. It's not possible. I can't understand what is happening with that. So this fact um, um, make me think a lot of about that. What happened with this subject? It's something that is only for one elite people and only super intelligent people, or what happened? Because I don't think I am a super intelligent person. I think I'm like a normal one. What happened with that? Why did this person need so many years to pass this subject? And that happened with many people in these years. The percentage of people that passed this subject was around 50%. Five. Around 10% of the people passed this subject. The 85 or 95% of the people can't pass this subject. So it was really, really frustrating for me to try to understand what happened about that. Now everything changed, and now almost 90% of the people pass this subject. It's not easy, but following this methodology, at the end, people learn, and people learn to do the same exercises that people before didn't know, didn't understood. So for you, for everyone, it's not easy, but let's go to do step by step, and at the end, the experience with the people like you, people from education, from marketing, from businesses, at the end, they learn to program. Not like an expert, but they do very interesting thing at the end. They resolve, last year, they resolved some games, programming games, with this methodology. So it's so great. You can see the videos, the last videos in English, from last year, and you can see what's the last exercise we did. I'm going to leave you in Moodle the link for the YouTube channel where you can find the last year videos. So it's possible to do. It's not easy, but working every day, I'm sure you can get the knowledge. This subject is not easy to leave everything to the end. It's not the typical subject that you can do nothing the semester and try to work very hard last week. It doesn't work here. In the same sense that it's not possible to learn to surf in only 2 or 3 days. It's impossible because you have to learn your brain and your body. And the only way to do that is to try, make a lot of essays, fold many times, and try again and again and again. they are not another way to learn a new paradigm. Is, as I told you, one of the most difficult things in life, probably, to learn something that is totally new. And this is the task we're going to you have in phase now. We're starting to learn something that is totally new for all of you, for people that program and for people that never program. Okay? And you have to realize that, because otherwise, if you try to reuse everything for the people that know how to program, if you try to reuse things, probably you will see yourself over the board, over the sea, trying to do something like that, like your steering wheel trying to drive the board, or your pedal accelerating your board over the sea. It doesn't work. So it's simple to see with this example. Okay. So, new paradigm. Okay, that is the main idea, most important thing to take into account, that idea. And now let's go to start with our first concepts. We can take a little break. What do you think about breaks? Because sometimes I talk too much, and sometimes that will be hard. And I think breaks are important. No? What do you think?
Breaks are always important.
Okay, 5 minutes, I'm back. 5 minutes, I'm back. Because we had this. Today is a hard day. Today is a hard day. Many important concepts. After that, you can see again the video if you want to repeat some ideas. But will be, if you have concentrate, will be nice, because you can ask questions, and that is the most important thing. You can ask what things that you don't understood. So it's very important you have to put the focus in what I'm trying to tell you. If you don't understand whatever thing, please don't worry, stop me and ask your questions, okay? Perfect, 5 minutes, I'm back, okay? See you. Okay. Sorry, I take a little bit more time, more than 5 minutes, sorry. Okay, let's go to continue. Are you ready? Okay, perfect.
Yes.
Okay, perfect. Perfect. I'm going to share again my screen. Nice. And let's go to see next concept, very important concept. We're going to use every day is the concept of mathematical induction. Mathematical induction. Okay. Probably people from, we say in Spanish, people from letras o ciencias. You know what that means? People from letters or science. You know what that means? We separate the world in two types of people. People that love to read books, literature, and so on, this type of things, and people that loves science. No? Is the same for you in your country? Do you have the same division of people in the world or not?
In Italy, we have the same division.
Yeah, yeah, okay.
Students.
So usually people from literature, or people from letters, we say here, or they don't want to learn about mathematics. Mathematics like a taboo or a bad words in their lives or something when happens. So it's the time to go far away. Mathematics. Oh, let's go. Bye bye. I'm going to go to another place. I'm going to the beach. I don't know how to learn nothing about mathematics. Okay, I am more or less in this way. I prefer to go to the beach than learn mathematics. But I realized that mathematics is like for me, it's like knowledge distilled. You know what the words mean? It's distilled knowledge. You know what is this? Something distilled? It's like a whiskey, no? You have a lot of information, or in the case of a perfume, you have a lot of essence or natural plants, and you make a process of distillation, and at the end you have a very small bottle where you have the essence of all these plants, no? Big amount of plants. So for mathematics, it's something like that. You have a lot of knowledge concentrate in only a formula. It's so interesting because many people do a lot of experiments to obtain this formula. So it's like distilled knowledge. It's knowledge in only one simple phrase or sentence. So that's it for me, mathematics. It's not something too complicated. Sometimes the way to describe mathematics are complicated for humans, but I'm going to try don't confuse with mathematics terms. Only try to give you the idea, because the idea surrounding this mathematics expression usually is something easy to understand, but this way to represent is needed because it's a way to avoid the questions about language, imprecisions about language. So for this reason, they use this sometimes ugly mathematics way to express things. But the most important thing is not this phrase. The most important thing is the idea. The idea is simple, very simple. And that is the thing I want to translate to you. What is the idea about induction principle? Okay, so please don't go to the beach now. Wait for a little bit later. Wait a little bit more. Induction principle, mathematic principle, or say here is mathematical induction. Mathematical induction. What that means? What's that? Okay. This is the base, mathematical induction. This is the base we're going to see this semester. Everything you need to remember, more or less, probably you need to remember a little bit more. But if you are very bad remember the things like me, you only have to remember these two lines. Okay, that's only. It's very simple and very, very powerful. It's like these beautiful things in the world that are simple, extremely simple, and extremely powerful. So what is the idea? Induction principle is one of the most usual techniques mathematicians use to demonstrate new theorem. So probably this idea is the most usual tested or proof techniques in science in general and in mathematics in particular, the mathematical induction. So how that works? So the idea is we want to demonstrate something. We want to demonstrate that if a property or an idea. I'm going to write in this way, idea. It's going to call idea or concept. A concept. P is true for a certain set of elements. Okay, we want elements. We want to know if something, a concept, an idea, is true for every element in a set. It's something like, okay, I want to know if every people in our classroom are Italian. This is the concept. Everyone in the classroom are Italian? Luca? Everyone are Italian or not? No. Malheureusement, dit en français, malheureusement, not tout le monde c'est italiano, mamma mia. No todo el mundo es italiano. Not everyone is from Italia, and this is the concept. So what is the set of elements, the people in the classroom? So it's always the same. It's very difficult to demonstrate something with every people in the world. We have to reduce to a set of people more we know. It's a classroom, for example, or whatever. Okay. So the main idea here is the people, the elements in the set. Let's go to call the set S. Have to be sorted. What does mean? What that means that the elements in the set have to be sorted. Do you think it's possible to sort people in the classroom? In which sense we can sort people in classroom? It's possible to put in order people in the classroom? In which sense we can do that?
By the name?
You don't know. Think a little bit. I need your brain 100% here. Think a little bit. In which sense we can sort people in our classroom?
Maybe from which country they come, the set is for them one.
Which country they come? Yes, but it's for example, what happened with people who come from Poland? We can put in order these people who come from Poland. It's difficult, no? Because who?
We can use physical attributes such as the age.
For example, exactly. We can put, for example, the age. We can sort people by age. It's one option. More options. And probably we can say who is the first one in our classroom. Let's go to try. Who will be the first one in our classroom according to the age? Who's the first? Who is the first one? Who is the first one? We can do a little test in the classroom. Who will be the first one? Who believe is the first, the younger person? Please collaborate. Tell one age, and let's go to check if there are another one younger.
22.
22. Who? What's your name?
Florian.
Florian, 22. Someone younger?
I'm
Yes,
20.
20. Who?
Elsa.
Elsa. Elsa. Is it's a way to write your name? Elsa, it's good or not?
It's good, you can leave it. So
Okay, Elsa. 20.
I'm 21 in the middle.
No, you are not younger. So, but it's possible to order people from the age, no? With no problem, no? Because it's very difficult to born exactly the same second, the same, no? It's very difficult that, no? Sometimes probably will happen, but it will be a little bit difficult, no? Exactly the same microsecond will be hard. So we can sort people in a classroom for this, in this sense, for age. So we need that to can use induction principle. If we can do that, we can use induction. It's very important. The most important thing that the elements in the set have to be put in order. And we have the first one and someone after this first one and so on. So we need this concept of order in this set, okay? Most important thing. Okay, after that, we know that Elsa is the first one in this set. She is the first one. Okay, let's go to call N0. It's more beautiful Elsa, but it's more easy N0. Okay. Okay, this is the first part of this induction principle. Let's go to use this concept of order. Okay, nice. So all the problems we are going to use okay, all the exercise we're going to use, all the set, all the type of data we're going to use have this concept of order. If not, it's not possible to apply this idea of induction, okay? It's very important, and we need to find this concept of order in each data type we're going to use. It's very important that, okay? To have always paid attention in this order. Who is the first one, the second one, and so on. Okay, perfect. Now, after that, induction principles say, okay, we want to demonstrate something, whatever, a concept, an idea about every people in the set, every elements in the set. So the first thing is the first part is the concept. Let's go to concept P. It's like a P in Spanish is property, or will be seed also concept or idea, but usually you use P. It's true for the first one. Okay, if I want to demonstrate, that P is true for all elements in set S, the first part is that the property P have to be true for the first one. It's a very, very important thing. Most probably, if not, it's not possible to use induction. So we need that. Wherever idea, concept, wherever problem I want to resolve with this idea, have to be true for the first one. So, for example, I want to create a program to say is everyone in the classroom are human. So this concept of be human have to be true for the first one. So Elsa, are you a woman? Are you a human? Sorry.
I would say so, yes.
Okay. Okay. Now, okay. First part is okay. So first part, Elsa is a woman. Perfect. Sorry, a human. Elsa is a human. So it's okay. Perfect. First pass of induction works. Okay, we have it. Second part. Okay, if we have people in order in the set, okay, we create a way to put the people in order, sort the people, for example, by age. And after that, we say, okay, if the property P, wherever idea or concept, I want to demonstrate P is true for n-1, I can say that P will be true for n. What that means? For example, in the example of human in the classroom, what that means? Who is n-1? We have Elsa. I need now that person with 21. Who tell me that I have 21? Florian. No. Who have 21? Who said I have 21? 21?
I,
I have.
me,
What's your name?
David.
David have 21. Okay, David 21. And who have 21? In which month? David?
June.
June 6. No?
Yes.
21/6. And who have also 21?
Me. I'm Leiva.
What's your name? Sorry.
Leiva.
Ui.
With L. Leiva. Yes.
Liva? No.
Yes.
Okay. What is your month? 21? What?
September.
September 9. 21. Okay, so who are younger? Who are younger? Levi is younger than David. So it's possible to put in order. What means n-1? Who is n-1 here? Is it the number 0, the 0, the 1, 2, and 3? Who is the n-1 of David? Who is?
I think the order is false. Lever must be after David. September
She born later, so
Yeah.
she's younger.
Oh, okay.
No? She born later, so she's younger. No? David born before is a little bit older. Okay, so who is the n-1 of David? Who is in this little example?
Leiva.
Perfect. Who is n-1 for Florian?
David.
David. Okay, this is the idea. We have people put in order or elements in order, and we can say, okay, who is n-1? So, and for every, this say, okay, for the second part of the rule, say, for all, for elements n greater than n0, let's go to call the first one n0, for all elements that are greater than n0, for all elements that are greater than n0, for all the rest of the classroom, all the people in the classroom, we apply this rule. So, human n-1, say it will be human n. Sorry. And this is the idea. So If we want to demonstrate for everyone in the classroom, we have to say, okay, for everyone in the classroom, if n-1 is human, the next one I can say that is human too. Okay, and that's all. This is the concept, the idea of induction. We are going to apply this simple idea for every exercise we're going to do in this semester. Okay, that's all. We have to apply this idea. Not always is easy, but this is the most important idea. The property have to be, first, the set have to be concept of order, or have to sort elements in the set. And the first part say the property have to be true for the first one, and for all elements in the set in S that are greater than S. We apply this rule if the property is true for n-1, I can say that this property is true for n. This is a logic rule. This is a logic rule. Let's go to talk a little bit about that. Or remember probably. What do you know about logic? What do you know about logic? Probably you have a previous knowledge about logic. Let's go to remember a little bit. What means that? What means that? For example, is what means that in logic? A row, B. What means that? Who can tell me?
If A is true, B is also true.
Exactly. But why I am telling something about A or not?
No.
I'm going to put you an example. Think about you are with your friend in Huelva, and you say to your friend, okay, tomorrow, if sun is shining, I will go to the beach. Something like that. Sun is shining. I will go to the beach. Okay, something like that. And after that, you say that today to the friend, and tomorrow your friend go to the beach and say, okay, what happened, Florian? You tell me you will be in the beach. Why are not here? And you can say, okay, I don't tell you that I will go to the beach. I told you that if, only if sun is shining, we read this rule like if sun is shining, then I will go to the beach. But only if that happens. This is the antecedent of the rule. We call to this antecedent, and we call to this part consequent. So if sun is shining, if this antecedent is true, then the consequent will be true. But I am not telling nothing about if sun is shining or not. I have no information about what will happen tomorrow with the sun. I can't say what will happen with Florian if we'll go to the beach or not. Only I will know if tomorrow the sun will be shining. Okay? This is a basic concept of logic rule. We are going to use rules in every program. So that is very important to remember. Probably you have some previous knowledge about that. It's very important that you remember that. The concept of rule and and facts. Logic are, we have rules and facts, or simple things that happens and that are true or false. In this case, if we write that, it have to be true. Okay, our logic programs will be a set of rules and facts. Our logic program will be a set of rules and facts. Okay. Any question about that? Please ask now. It's very important to understand that. Tell me, someone is the first time that I listened about logic? Everyone knows a little bit about that?
I think for me it's the first time.
For you, it's the first time? Okay, it's not a complicated concept, but it's important to understand that what means a logical rule, okay? You understood?
Yes.
Yeah, I think
Okay,
so.
okay, perfect. Let's go to practice every day with this concept, so probably we will reinforce the idea. Okay, perfect. So in this case, if the property for n minus 1 is true, I can say the property for n will be true. So in the case of human people, I can say, okay, if the n minus 1 is an human, I can say that the person is, the next person is an human too. You can think about the concept of human like your father, grandfather. And you can say, okay, if my father is an human, I can say I am a human, no? Something like that. In this case, the n minus 1 is not the age, is the concept of descendant of one person who is the father of another person, and so on, the father or mother of one person will be the relationship, the order. So in this, if we apply that, we can say we are humans or not. What do you think? Who is the first human? Who is the first human? What do you think?
Sorry, can you repeat this part, please?
Who is the first human? If we apply that, you think it's a first human, that first one, and after that we have a son, and also this person have another son, until Luca, Italian man. What do you think? If we apply this rule, you can say you are a human or not.
Yes, of course.
Why? Who is the first human? Apply induction. Who is the first human? We need the first one. Who is the first human? What do you think? He's a monkey? Or what?
Choose a monkey.
Or who's the first? Because the theory of Darwin say we are not human. If we apply Darwin theory, we are not humans. Probably we are, I don't know what. The theory of evolution of a species, no? Applying this evolution induction principle, we are not human. I don't know what we are. Do you understand me or not?
Okay, so here you are saying that it is impossible to find n0 for this kind of predicate. That's what you're saying.
Yeah. If we think about who is the father, your father, and your grandfather, and so on. Who's the first human? Who is the first human? Exists this one or not? If not exists, we cannot apply induction. It's a middle joke about that, but it's interesting to think about that. No, who is the first human? Okay, let's go to live here. This is only one idea to try to simplify what is the concept of induction. We can apply to many different concepts, but we are going to apply with numbers on this, more simple than apply to humans. Okay, perfect. Any question about induction? You understood? Everyone understood induction? Someone not?
Yes, I think so.
Okay, more or less. Okay, perfect. Let's go to apply that idea with a more simple concept, more simple than human. This will be more complicated. Let's go to apply to create our first program. Let's go to create our first Prolog program to say if a number is natural number of not natural, the concept of natural number. Natural number. I'm going to explain you what that plus here means. Forget this plus now, but have one sense. It's only, it's not part of the code. This is a comment in programming languages. We can use this symbol in Prolog. Prolog comment to put some explanation about the code. So it's usual to have these lines that are not part of the code, but help us to understand what is happening here in this code. Okay, so we're going to use that frequently to create some comments in our code. So and the explanation for this natural, we always use one explanation or a line that will tell us what that means, this concept, or when that is true. Natural, it is true if number is a natural number. Okay, and with this concept, we are going to evaluate and we'll tell you if that is true or it's false. For example, we can ask natural, the number 5. We can ask to Prolog, hello Prolog, tell me, natural 5 is a natural? We can ask that, and Prolog will say yes or not. What do you think will Prolog say to this question? Number 5 is natural or not? What do you think? Is number 5 natural? Natural number? Prolog say yes. Okay, it's a natural number. Okay, let's go to create this program. Using induction, let's go to create our first program in 10 minutes. Okay, using induction principle, using mathematical induction. Okay, let's go. First part of induction. What say? How to write this concept? This first part of induction. Who can tell me what is the first part? What I have to write here? Who is the first natural number? What is the first natural number? I need your help.
It's 1, right?
Number 1, exactly, because number zeros, they are number 1. 1 is the first natural number. Okay, how we express that in Prolog? We say something like that. Natural 1. This is a way to say that natural one is a natural number. It's the name of the concept, in this case is natural, parentheses, and inside the number, and parentheses, and at the end, one dot. This is a way to express, this is a fact. This is a fact, a simple way to express the idea of one is natural, okay? Second part, please help me, I need your help. Tell me what is the second part of induction for naturals? I have to write something like natural, the n-1. If that is true, then natural, the n will be true. This is the idea. If natural, the whatever is true, then the next one will be true. It's okay? How we express that in Prolog? Here, there one interesting thing. In Prolog, rules in this way, we change the order. This is in logic. This is a way to express a rule. Rule in logic, we usually write in this way, but a rule in Prolog, we change the order, something like that. It's like B, 2 points, and A. We change the order. Here, in the right side of this rule is the antecedent, and C is the consequent. B is the consequent of the rule. We change in Prolog, we change the order. So we have to express this line as a logical rule in Prolog. How we say that? Natural, the n in variables in Prolog starts with a capital letter. That's important too. Variables in Prolog starts with a capital letter. Okay, so this is n, but in Prolog we have to write in this way. This is this part, natural the n. We change the order and put at the beginning. And now what I have to say is for n is greater than first one. First thing I have to say here is that works if n is greater than 1, because the second part of the induction, we apply this rule for elements that are greater than the first one. And the first one is number 1. So if n is greater than number 1, what we have to do? Who can help me with this part? What I had to write here? I am translating this line, number 66. I'm trying to translate that to Prolog. I write this part because the order in Prolog is, I put in the reverse way in the rule. I put first the consequent, and now all this part is the antecedent, is here. What I have to put here? Please help me. We have only 12 minutes to finish the code.
Natural n.
Natural
N.
n. This one, no?
No, because I don't know, but you said that in Prolog it's inversed. So
yeah, we have to change the order. So this part here is the consequent. And now I am writing that here.
Okay.
So what I had to write here?
So natural n minus 1.
Okay, but in Prolog, it's not possible to do directly. I have to use another variable. And 2 is, let's go to see later what that means, but it's not possible to use directly. I have to create a new variable because the concept in Prolog of variables is the concept of mathematic variables and not the computer science. In computer science, a variable in computer science, a variable is like it's equal to a box or memory position, something like that, where I can put things inside this box or variable. But in mathematics is a little bit different, or quite different. Is in mathematics, a variable is different. Variable is a tool to define a concept. Put here one example. For example, remember if you were your first lessons in, I don't know which mathematics lesson, or you never see this description of a theorem. Theorem 1. I would say let x a natural number. Let x greater than 5. That make you use. Did you see some time in the past the theorem definition or never? Did you see sometime? It's something like that. It's like this is a theorem, and we just use variable like a tool to describe a concept. So you start telling things or putting properties to this variable, and at the end you have a full description of these variables. Let's start it like to say, okay, Benjamin is a person, and Benjamin have, I don't know, 20, 21, 22 years old.
24.
24, very young person, 24 years old, and he's from and he's, I don't know, 2 meters tall. He has blue eyes. I don't know. He has a beautiful girlfriend. I don't know, whatever. So at the end, this variable that's in Benjamin, I describe you. It makes no sense after that say, okay, and Benjamin is, I don't know, a car. Have no sense. Because Benjamin is a person, I am describing, it's not have no sense to say Benjamin is a car. Benjamin is not a car, it's a person. So this is the concept of variable in mathematics. Like this, it's a tool to describe a concept. In computer science, a variable is a box where you put things. You can put a car, can put a person, and after that you can put a train. Doesn't matter. It's a different concept. And in Prolog, the concept of variable is a concept of mathematical variables. Okay, so for this reason, it's not possible to put here n is n-1 because n is a concept of a number or whatever. I can change this concept and put another thing inside. So in Prolog, the variable, once it take one value, it never changed until the end of this line, until the dot. So if n here take a value, it doesn't change. This n is the same here, and here, and here at the same variable. And if I write in other line another n, is a different n. Okay. Okay, let's go to work about this concept more frequently. Today there are many things new for you probably. Don't worry about that. Don't worry. Let's go to repeat again next day this concept because that are very important. So let's go to finish this code if you want to test at home your first program. Okay. And what do you need? You need this programming language. You need to obtain SW Prolog. You can find here, this is the site. This is the site, the website, sorry, is SWI Prolog. Here in download, you can get this program and install. It's very easy. You have to visit this link, a stable release. You can here go to a operative system version. I'm going to install in Windows. Here you have to understand and click here download. I have already downloaded. I'm going to execute. Execute that. Double click over the name, and this say, do you want to uninstall? Yes. Uninstall before. Let's go to uninstall. Uninstall option. You can use up the name of the program to the path because it will be more easy to find it. So you can choose this option, add to the path for all users. This is the path or the way where the code will, or the files will be installed. Say program files. And next, this is the name of the folder. Next, this is the components for the folder. You can leave everything and install. Now it's not working because I have this already installed. So I'm going to omitir. In your case, you will install without problem. I have some problem because I have to uninstall before. So, okay. Now, if you have installed this code, you can access here with Prolog or Prolog. I don't know why it's not here, because probably it doesn't finish properly installation. Okay, I'm going to remove before. I'm going to remove. It's not here. It's not installed. Let's go to see what happened. Okay, it's the error. Choose this option. Installation. Okay, I don't know what happened. Probably is, I know. I have this program open, so I have to close that window. Probably it's only that. Okay, now it's working. Sorry, The problem was I had this window previously open. Okay, so we have only 2 minutes. I'm going to show you how that works, and next day we will continue here. Oops. Sorry. Sometimes need some to appear here. I don't know why. Here is the program. Okay, this is the aspect this program have, and let's go to save this file. To edit the program, you only need one editor, like for example this one. Have no any extra code, and the part we only need to create this program is this line and this line, these 2 lines. Paste here. This is the only part we need. This one, and I'm sorry, and this one. Oops. Okay. Save as for example, natural dot pl is the extension. Okay, and now you can open here, consult. Okay, there are no errors, and now we can ask, for example, for natural, the number 5. And people say that's true. Okay, so finish. Let's go to live here, and we will continue next day. Okay, are you there?
I have question one.
Okay.
So will the whole semester be online?
I don't know. I don't know. It depends on what is the situation.
I have a question about the final exam, because if it will be not online, I will have to go to the university. So I really prefer to know, because I want to know when can I come back to home.
Okay. Usually we're going to create a final project, so you don't have to do an exam presentially in the university. So you can do your project at home, following the lessons, and finally do your exam at home.
Okay.
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 Okay. I don't know what is your feeling about the first lesson. Don't worry if there are some things that you didn't understood. Next day, let's go to repeat again the main concepts about induction, and repeat again this exercise and explain more and see it more deeply. Okay, so don't worry. I have to say we have 2 lessons a week. I don't know if you know about that. We have today, and we have another lessons of 2 hours. I don't know exactly now if Wednesday or Thursday. I can send you a message in Moodle to tell you what is the day and the hour. Okay, you know that or not?
No, I don't know that.
No, it's the first time we heard something like this, I think, because in the schedule we had like just one lecture in a week.
Interesting. That is very interesting because every year happens the same.
Yeah, also on the course selection page, Delex, they're standing yeah, only the Monday lectures.
Yeah. Okay. Okay, don't worry. Don't worry about that. Probably we have to reduce. Okay, don't worry. Let me talk with the person that published the information, because it's not I don't do that, and I will try to find a solution for you. Okay, don't worry about that. Don't worry about that. Let's go to do as better as we can. Okay, don't worry about that. I'm going to resolve that, because it's always I don't know why it's always the same. I tell many times about please specify we have 2 lessons a week, but I'm tired to repeat that, and every year happens the same. Only 1 lesson a week is published. I don't know why. Don't worry, doesn't matter. Don't worry about that. If you have the contract of the reason you take this lesson is only once a week, let's go to have once a week. Okay, probably the other day will be like a question day. For if you have any question, you can connect to resolve your question the second hour. Okay,
Yes.
like
Yes.
okay, like 1-to-1 lessons or a question lesson day or whatever. Okay, let's go to try to adapt to the situation, because otherwise will be very difficult. I don't know why that happened years after year. Okay, but don't worry about that. Let's go to resolve. If you have the contract when you inscribe in this subject only once a week, let's go to have only once a week. Okay, and the second hour will be time to resolve questions. Okay, or if you want extra time to do more exercise, you can use the second hour. Okay. So,
I have one more question. So is there another option for Prolog? Because my Mac says, yeah, you can't download this and it doesn't work. Also, if I go to the settings and change things, it won't open.
did you say another option different to Prolog?
Yeah, maybe, how could I say that? Maybe there are some other source where I can download that.
Yeah, we can use other option, but I can tell you next day. Okay, I can tell you next
Okay, no
day.
problem. Thank
If you have some problems to install, please you can try next day. I did today only to show you first time, but I can do next day with all together. We will try to install. Okay. Don't worry, because today I want to first day I want to do many things. I know I went a little bit fast, but this is not the idea. The idea is to you understand everything. So don't worry. Next day, let's go to repeat again, whatever concept is needed. And at the beginning, it's very important to understand everything, because later we are going to make more complicated exercise. So it's very important at the beginning to understand everything. Okay. So see you next Monday.
Thank you.
And
See you.
Thank you very much.
Bye.
have a nice week.
Thank you.
Bye.
Thank you.